Okay, so here are two more examples of stoichiometry problems using this new concept of molarity, where molarity, remember, is moles per liter. So in doing these problems, we're going to use the same flow chart as before. We just have a new way to get to moles, which is molarity multiplied by volume in liters. So let's talk through this first example. And the one change I've made to this example versus what I had previously published on the slides is that I went ahead and put the volume here in liters instead of milliliters. But hopefully you could see that 25 milliliters is the same as 0.025 liters. Okay? So I just wanted to note that in case you have the PowerPoints printed out that I had posted previously. But let's go ahead and attack this problem. Let's say I have this balanced chemical equation of nitric acid and calcium hydroxide reacting to give me liquid water and calcium nitrate. So I have this balanced chemical equation. It's an acid-base double displacement reaction. And I want to know how many grams of calcium hydroxide, so I'm looking for grams of calcium hydroxide, are needed to neutralize or react with this volume and this concentration of nitric acid. So in our little flow chart here, we have the molarity and volume of some substance, and we need to find how many grams of a different substance react with that. So we can use this flow chart along with the modifications to do that problem. We can start with the molarity and the volume that's given for HNO3 or nitric acid. And note that when I wrote the molarity down, I wrote it so you can clearly see that moles is in the numerator and liters is in the denominator. So 0.100 molarity of HNO3 is exactly the same as 0.100 moles of HNO3 per liter of HNO3. And when you multiply that by the volume that's given in the problem, your units cancel. You're left with moles of HNO3. So we are now at moles of nitric acid. We can then use the coefficients of the balanced chemical equation to go from moles of HNO3 to moles of calcium hydroxide. That's a species we're looking for. And so from the balanced chemical equation, we see for every 2 moles of HNO3, we have 1 mole of calcium hydroxide. So we write that, so our mole units cancel. So this mole HNO3 unit that's in the denominator cancels all the way with this mole HNO3 unit that's in the numerator. So we're left with moles of calcium hydroxide in the numerator. Now we just need to go from moles of calcium hydroxide to grams of calcium hydroxide using the molar mass of calcium hydroxide. So 1 calcium plus 2 oxygens plus 2 hydrogens gives you 74.10 grams. That's how many grams per mole of calcium hydroxide. My moles of calcium hydroxide cancel. And then when putting this in your calculator, and if it makes you feel better, you can put this over 1. When putting this in your calculator, you should get 0.093 grams of calcium hydroxide. Okay. So in doing this problem, we used steps that we've used similarly. The only thing that was changed was that we got to moles through a molarity and a volume. So let's try another example. So in this example, we have sodium hydroxide as a reactant, and then we have this new acid, sort of a mouthful to say. It's called potassium hydrogen phthalate. And the reason why I chose this chemical reaction and problem to do is that in lab, the very last lab that's scheduled to be done in this lab is a titration lab, and it's a lab that makes use of this chemical equation. So I wanted to introduce it to you now, so if you see it later on in lab. It won't be so scary to you. But it's just an acid-base reaction where I have this potassium hydrogen phthalate, which sometimes we abbreviate as KHP. But this is the chemical formula, molecular formula for KHP. That KHP reacts with sodium hydroxide to give you liquid water in this salt. And I want to know from that balanced chemical equation how many grams of potassium hydrogen phthalate will react with that volume and this molarity, that concentration of sodium hydroxide. So hopefully you can see that attacking this problem is going to be the same steps as what we did with the previous problem, which is using the molarity multiplied by the volume of sodium hydroxide. And when doing, you can think about that as being over 1 if you want. And then when doing that, we have moles of sodium hydroxide. Then we can use the coefficients of the balanced chemical equation to relate moles of sodium hydroxide to moles of potassium hydrogen phthalate. Specifically, for every 1 mole of KHP, or potassium hydrogen phthalate, I have 1 mole of sodium hydroxide. This mole of NaOH in the denominator, that unit cancels out with this mole NaOH in the numerator. And so then we can finally go from moles of potassium hydrogen phthalate to grams using the molar mass of that big acid. So specifically 1 potassium, there are 5 hydrogens, 8 carbons, and 4 oxygens. Adding up those atomic masses should give you 204.23 grams. Mole units cancel here. And so then when putting this in your calculator, everything in the numerator multiplied, everything in the denominator divided, should give you 0.60 grams of potassium hydrogen phthalate. Okay. So that's how we use a volume and molarity in doing stoichiometry-based calculations. I have, I think, 1 or 2 more examples on Canvas that you can try. I will also have one on a bonus for this chapter that you can try your hand at as well.